Hello. It is the 16th of October, 2015, and this is episode 29 of the Unseen Podcast. I am tonight's host, Paul Carr, and joining me tonight are Adam Synergy Smith. Say hello, Adam.
Hey, everyone.
And
good morning, England.
Yeah, it's morning in England. Buckfield.
Hello from Patagonia, Chile.
James Garrison.
Hello from the middle of the country.
Which country is that?
Whichever one they want.
And Mike Bohler.
Greetings from Chicago.
All right. And now, Adam, I'd like to thank Adam for hosting last week. I was on my way down Interstate 81 to Tennessee when the show came on, and made my life a lot easier. And hopefully, Adam, you'll get a chance to do it again sometime before too much longer. And I should point out, in a couple of weeks, James will do another host gig where we're going to talk about cryptids and cryptozoology and Bigfoot and all that fun stuff for our Halloween show. That'll be on October 30th where we record that. That'll be out on October 31st, Halloween. So hope you guys will tune into that one. It should be fun. Next week, we'll Next week we will have a practicing transhumanist on the show. I know some of you are skeptical about some of the things that he does to himself, and that skepticism is welcome. And he's ready to answer your questions. So if you have questions for him, please email them to unseenpodcast@gmail.com. If you have any questions at all for me or for the rest of the panel, or comments, or if you want to correct something that we said that was wrong, also email unseenpodcast@gmail.com, or go right to unseenpodcast.com and click on the episode that this corresponds to, episode 29, and make a comment. We'd love to hear from you. Okay, tonight I think we'd like to talk a bit about some of the things that popped up this week. We were struggling a bit with the topic for this week's show until Tabitha Boyajian's paper showed up earlier this week on Archive, the preprint server, and Jason Wright put out a blog post talking about how the genesis of that idea in the paper. It had to do with some very strange data in the Kepler data set. And we'll get into that in just a moment. Jason Wright himself also put out a paper about 2 days later, which follows up on GHAT. And as you might remember, we discussed GHAT in episode 5. We'll have a link to that in the show notes. We'll have a link to everything in the show notes. Just go there at unseenpodcast.com, and you'll find all the information that we're discussing tonight. And, of course, my esteemed panel will be eagerly digging up links to send to me to put in the show notes as soon as we go off the air. Now, let's start with the paper itself, which I personally think is quite good quality work. It's a large team of astronomers. Does anybody want to describe in their own words what's in that paper, or do you want me to try to tackle it?
I'll have a go.
Thanks, Adam.
Okay. So the paper centers on the Kepler Space Telescope's photometry of the star KIC 8462852, which is a pretty average, unremarkable F-type main sequence star. It has a rotation period of something like 0.88 days, which is consistent with that sort of star. And in all respects, it appears quite unremarkable. But the light curve produced by dips that are normally signify a transiting planet are very, very strange. They're like nothing that we've ever seen before. A planet will produce a very typical dip in the light curve. It's usually very symmetrical and periodic. They come around every time the planet orbits the star, say every 10 days or 100 days, whatever. This light curve is all over the place. It's got big dips, large dips, very fast dips, quite slow dips over periods of 80 days, something like that. Very, very strange. And it was flagged by the citizen scientists on the Planet Hunters website, which is part of the Zooniverse set of citizen science projects. It was flagged by a number of people as being very strange. And so Boyajian and her team set about taking a look at it.
Yeah, now, we should point out that this is a star that's about just under 1,500 light years away, and it's what they call an F-type star, which is a little bit larger and brighter than the sun, but not dramatically, right? So, and it's spinning very fast. It has a period of about less than a 1 Earth day. So it's an interesting star, but it's not, as Adam pointed out, it's not a particularly unusual star. Anything else about the light curves you wanted to say, Adam?
Just that they're exceedingly difficult to interpret. There's no signs of any planet transits in them at all. None whatsoever. So whatever is causing the dips in the light curve is it's not spherical. It's certainly not a planet, and it's nothing that's of a regular shape.
Right. I think the most notable thing about the announcement was the hypothesis put forward that this could be evidence of alien megastructures around the star.
Well, and I should point out, Buck, there really wasn't an announcement. There was an article in, I think it was Slate, by somebody who'd interviewed her, but the science team said nothing about alien megastructures.
Well, every coverage that I've seen has mentioned that.
Yeah, but it's not been the science team that proposed that. Now, Jason Wright.
The science team proposed.
Go ahead, Adam.
The science team proposed a swarm of exocomets. That's the best explanation they can come up with. Although they do point out that there are some features of the data that don't quite fit that explanation.
Yeah. In their paper, they go through a lot of candidate explanations, right? That they really don't leave anything out. They've got another thing that I would note about this star. They did a fairly detailed spectroscopic analysis of the star from ground-based telescopes. This is not all the data is from Kepler. It comes the dips in the light curve are from Kepler, but they followed up with a lot of analysis from ground-based telescopes. They found that the star is rotating at an inclination of about 68 degrees, which means you wouldn't expect it'd be very likely you'd see planets transiting at all. It's not spinning in the right direction, and you'd have to be very lucky to see planets transiting. But so yeah, whatever this thing is, whether it's natural or not, it's weird. And also the dips are, as Adam pointed out, some of the dips are very, very large. I believe one goes up to 22% of the star's luminosity. And that is just crazy. I mean,
totally unprecedented.
Yeah. I mean, usually they're very subtle dips that they see. Even but big
normally
planets.
a large Jupiter-sized planet, you might expect a dip of around 1%.
Yeah.
So 22% is just crazy. Yeah.
It's huge, but it's not another
Yeah.
star.
Well, there is another star that's a candidate for a potential binary companion,
Right.
a small red dwarf M-class star. That it's a separation of around 885 AU, but they're not totally sure whether or not it is a companion star or whether it's just passing through perpendicular to our line of sight. If that's the case, then that does offer a potential explanation.
Well, but
because-
even that doesn't, I mean, that would not cause a that big a dip in the light curve and without an incredibly fortuitous eclipse.
No, the star
not
itself
repeating
wouldn't, but it's
dip either. So, I mean,
no,
the
but
problem
it's
you have,
gravitational influence
Yeah.
on. There's the possibility that it's gravitational influence on any planets orbiting the F-type star. It might have disrupted those planets, causing collisions. What we might be seeing is the destruction of a planetary system. It's a possibility.
that is possible. It's unlikely for the reasons stated in the paper that to get a 22% obscuration of a star, you have to have an enormous object.
Yeah, I've been thinking about what the consequences might be if Jupiter and Saturn collided. What the potential for obscuring a star might be if all the gas in Jupiter and Saturn were flung out all over the solar system. Would that create those kinds of dips as seen from another star system? I'm not sure.
I don't know either, but I think that there's going to be a lot of modeling going on in the next few weeks.
Mhm.
Yeah.
Somebody trying to come up with an explanation. It's but you take gas giants and bang them into each other, as improbable as that may seem. They have such powerful gravity. I don't think you're going to see a huge amount of clouds coming out of that. You'd see a lot of energy released.
Yeah. Well, the other piece in the puzzle is the lack of any infrared excess. They took a look at astronomers took a look with a ground-based infrared telescope, and they found no significant infrared excess.
Yeah. Plus, there's data from WISE and I think 2MASS.
Yeah.
So they have,
Which-
and they can't model a statistically significant infrared excess there. If it
No.
So a lot of people would say, oh, it's a Dyson sphere, but a Dyson sphere would have a big IR excess. So it's not a live operating Dyson sphere. It might be something else, but it's very early days on that. I thought that Dr. Boyajian's team did a fantastic job of documenting their work and trying to rule out everything they could think of. And if you read Jason Wright's blog and his paper, he doesn't think the comet thing is at all probable.
No, it doesn't sound very likely.
I mean, you'd have to have a lot of comets, enormous quantity of comets, all lining up in a big cloud, which, maybe with the modeling that we'll see over the next few months, we'll think a way to get there. I mean, every time something like this comes up, it's a surprise, but then we go away a few years and come back and we think we understand it. Like neutron stars were theoretically projected, but when the first pulsars showed up, it looked really, really weird. It looked almost like an alien radio beacon. And it didn't take that long to figure out that they were in fact natural objects.
But they're still pretty weird.
They're quite exotic.
Yeah.
I mean, they're
They're not alien. They're not the LGM.
no. Well, they actually the term LGM got thrown around a bit. Little green men when the first pulsars were detected, but astronomers, being good scientists, first tried to rule out natural objects and could not. They found that, hey, if you have this neutron star with a very strong magnetic field, which it will have, rotating very fast, you can get these kinds of pulses, and it fits all the models. So it took a lot of work to get there, but they found it out that that's what it was. Same thing with quasars when they were first discovered. Nobody knew what they were. The same thing with gamma ray bursts. When gamma ray bursts first discovered, all we knew was that there was this enormous release of energy somewhere out in space. We didn't know where it came from. With quasars, same thing. We saw these incredible release of energy, didn't have any idea where it was coming from. A lot more study, a lot more observation, a lot more theoretical work. And, now starting to converge on what those are. Well, I think with quasars, there's really very little question of what they are. Gamma ray bursts are pretty much there as well. So all these phenomena come up. Another phenomena was the hot Jupiters. Nobody predicted those before exoplanets were discovered. Now they have plausible mechanisms for how hot Jupiters form and migrate inward. And it took a lot of modeling and simulation to get from the observation to understanding how they can be physically possible and even probable in some cases, depending on the initial conditions. So hot Jupiters, when I first saw hot Jupiters, I thought, aha, the aliens have figured out how to tap into the orbital energy of large planets. And, well, it was a good idea, but reality is that...
You really thought that when you first heard this?
Well, I had no idea. We know that a Jupiter can't form at those radii. A gas giant can't form it, so it had to migrate in. So something made it migrate in. My first thought was, well, if you look at the energy that's stored in Jupiter's orbit, it's enormous. It could power the Earth for billions of years. It is a huge amount of energy. And if you move, I calculated once, if you move Jupiter from Jupiter's orbit now into Earth's orbit, how much energy you get, it would just be astonishing amount of energy. And that's that was a thought I had. Now, we now have a pretty good idea of how these big planets can form out in the cold depths away from the star, and then by interaction with the dust disk, migrate in. And it happens in the first few million years of the life of a solar system. It's an early thing. Our Jupiter probably migrated in, then migrated back out again. And,
I didn't know that.
We would not exist if it had kept coming in. Probably would have thrown us out. But all that happens in probably the first 5, 10, 15 million years, which is, the infancy of the solar system. So the point that I'm trying to make is we find weird things in space all the time. Well, not all the time, but we find weird things in space from time to time. And so far, the history has been that we figure them out within the current paradigm of the physics we understand and the astronomy that we have. And this one has not been figured out. So it's exciting, even if it turns out to be a natural object. It's
a mystery.
It's a weird natural object. And as Adam pointed out, the first dip was quite a bit different from the second set of dips. So something evolved between, and these were about 800 days apart? Was that
About 80, I think.
80? The first big dip and the second dip, they were
All right, yeah.
they were about 800 days apart, I believe.
Yeah, right.
But they were very different in character. So either whatever it was two different things or something evolving that was the same thing.
Yeah.
It sounds like a couple of asteroid belts.
Well, an asteroid belt wouldn't do that. It wouldn't create. You couldn't create 22% obscuration of your star.
Too much open space between the rocks.
Well, yeah, the rocks are really small compared to the star. This is a star that is bigger than the sun.
Yeah.
It's probably close to 1 million kilometers in radius.
Yeah.
So
something obscured a quarter of the total size of the star and then disappeared and wasn't seen again. That's totally bizarre.
Well, we haven't given it time to come back. This happened over 1,500 days?
Yeah. It's unfortunate that the Kepler Space Telescope is no longer observing the Kepler field.
Yeah, well, we could keep an eye on that particular star but probably not 24/7 like we were.
No, I think what we really need is radial velocity measurements to look for planets.
Well, they did do. I should point out they did do They didn't do a complete radial velocity profile, but they did do spectroscopic studies from ground-based telescopes and got very little change in radial velocity over time, which rules out large planets.
Yeah, I also think they should do a characterization of the M dwarf companion. Look for planets around that star as well, because if you are going to go with the alien megastructure hypothesis, the candidate star system from which any aliens might come from would be that one. You wouldn't want to obscure your own star, would you? You'd totally ruin the daylight on your own planet. So it would make sense. It would make sense to use the other star in a binary system, not your own.
That's actually, I don't think I've heard that idea before, Adam. That's a good one. Yeah,
Very interesting.
If that is a fact a binary companion, they're not sure. There isn't enough data to determine if that star is just wandering through the same field of view or if it's gravitationally bound.
I would say it's likely. The chances of it being in the same space at the same time are pretty slim. It's quite likely to be a companion, but we're not 100% sure yet.
Yeah, because we don't have parallax on either star. We don't have, so we don't really know exactly the distance measurements are very imprecise.
Yeah.
So they're off. They could be off by, well, not by light years, but it could be off by. Well, it could be off by a light year or two. Yeah.
Yeah, sure.
Because what they do is they look at the brightness of the star and they say, well, we know about how far away it is because we know how bright it is and how bright it should be. So they are able to estimate the distance from that. But apparently it's not in the Hipparcos catalog, so it didn't get its parallax hasn't been measured, and it's pretty far away. It's over.
I doubt Gaia's got around to doing any measurements of it yet, because I think it's concentrating on the local solar neighborhoods first.
I don't think have they even published a catalog from Gaia yet. I don't think they have. But
not officially, no.
No. And by the way, anybody, I'll put a link in the show. Anybody can look up these things in Simbad, which is this lovely database that's available on the internet. And you can go and see what measurements and what data are available for any star in the sky. You can search by the name of the star or the number of the star. You can search for a range of parameters like distances or constellation.
Paul,
Yeah.
could you finish that thought? You said something about the companion star maybe over 500, and then you switched. What was you were about to say something about the ranging of the companion star, I thought.
Oh, well, we just don't know. We don't know if the companion star is. We don't know it's a companion star. It may not be a companion star. It could be close. It could be too far away from the F class star. We basically have a two-dimensional image.
Okay, so no ranging has been done.
No, there's no parallax measurement. They can roughly estimate the distance, but there's error.
Mhm.
So
Yeah.
it could be further away or closer. And if they're roughly the same distance, then they could be companions. And this is something the astronomers can determine with a little bit of effort and observation. Is this star a companion star to the star of interest here? The number of which I forgot already, but Adam said it earlier. But that's
it's a separation of 885 AU.
Yeah,
that's two-dimensional.
Yeah, that's assuming they're roughly the same distance away from Earth.
Yeah.
In which case that would certainly be a binary companion, if that was, that would be within the sphere of influence of that big star. This is a star that's about 40% more massive than the sun. So it's got probably the same stuff that the sun has. It has an asteroid belt. It has an Oort cloud. It has a Kuiper type belt. It probably has planets, but the planets are operating in an inclined plane that we can't see transiting. And they're not close enough that we can see the change in radial velocity. So they're farther away from, I think, what did they say in the papers, Adam? I think it's like they couldn't see something. I'd have to look it up. It's something like 5 Jupiter masses within an AU or something like that. It could not be detected.
Yeah, I think it's within 3 AU, something like that.
Yeah. So there's not a big planet orbiting close. There could be a big planet orbiting further away or a smaller planet close.
But is there any identifiable cycle, like a major cycle, like maybe there's a stock market variation, but there is a repeating cycle that's been detected in these measurements?
No, they haven't done enough measurements.
Okay, so it could just be a bunch of like a cloud of crap that's floating in front of it.
Well, it's a very large cloud of crap.
It could, but they detected no infrared signature. You would expect dust to show up in the infrared.
Yeah.
What if it was a lot closer to us?
It wouldn't make any difference. How many even closer to us?
Yeah, like what if it was a big a cloud of debris that was a lot closer to
within our own solar system, or?
Well, no, I hadn't imagined that, but I would expect that would be pretty easily detectable.
Well, if there had been a single event, you might say, okay, it was something else past that very large, but doesn't give off light that passes. But see, the point is you get large enough to obscure it. Either it's got to be real close to us, or it's got to be giving off light, or it's got to be something like a black hole or something like that would, but it would only pass by once. It wouldn't pass by twice.
It's 1,500 light years away,
roughly. Yeah.
Okay, so what if this was some crap that was 500 light years away? If there's no periodicity to it.
Well, it has to be almost as big as a star, right? But not detectable as a star.
Would it?
Yes. Well, think about it. It's covering an area that's almost a quarter of that star. And
Well,
And
but your thumb will cover the moon. So
if it was something like a free floating planet or something, it
Yeah.
would be detected in the infrared. And it
Well,
doesn't show up.
it wouldn't pass by twice. It only passed by once.
But you said there was no periodicity that was detected.
Well,
So I'm thinking about, what if there's just like a debris cloud that's in relative motion between us and this star, not necessarily orbiting that star, but
there are two distinct groups of events. Let me put the I'll get the PDF up and I'll put it up so everybody can see it.
okay.
And folks who are listening on audio, there is a link in the show notes. The paper is called Planet Hunters X KIC 8462852 - Where's the Flux? So a lot of people have been calling it the WTF star because of the Where's the Flux. Apparently, Dr. Boyajian likes to give clever names to her paper. She did another one called How to Constrain Your M dwarf. And what we're waiting for right now is me to get my PDF viewer launched, and I will share that with the panel and anybody else watching. By the way, if you're watching, we have Q&A up, so feel free to.
Yeah, we've got a few questions from Patrick.
Okay, let's field those in just a minute.
Yeah.
Okay.
Adam, could you catch me up to speed really quickly on how do we know free-floating debris has a significant infrared signature?
Basically, that is how we would detect it. Either it would occult something in the background, which is what I think you're talking about. Perhaps this is an object in the foreground occulting the star behind it.
Mhm.
If that were the case, you would expect it to occult not only this particular star, but this M dwarf that's close to it. And as it moves, it would occult a whole lot of other stars. Either that's not what we see. And you would only get one occultation as it passes in front of the star. You'd get a dip in the light curve, and then that would be it. But in this particular instance, we see a whole number of different dips, and they're all different ranges. Paul's got the
and I've got it up now.
And you can see there are different dips which correspond to something obscuring the star.
Not only are they
at different days. You know, there's one there at around 800 days.
Yeah.
And then nothing much until just after 1500 days, then a whole series of dips, you know, and they're all different sizes, which is crazy.
Yeah, and you'll note that
if there were, there's no.
Go ahead, Adam. Sorry.
There's no periodicity to it. If it were a planet, you would expect to see the same size dip every, I don't know, say 100 days or whatever.
Yeah.
And the dips would be symmetrical. It would steadily decrease as the object passed in front of the star, and then you'd get the same increase as it passed the other side of the star.
Yeah.
And these dips in flux aren't symmetrical at all, which is why we know that it's not planet transit.
The other thing that's quite interesting is just the sheer size of them. I mean, the first one is about 15%, which is enormous. And this one is even bigger, at around a little bit after 1500 days. By the way, this day scale here is, I think, from the start of observing time. So this goes out about 5 years or so. So at day 800, they got this one Well, they get a little bit of raggedy behavior, and then a massive dip, and they show a zoom in on it. You can see it's asymmetric. It dips. It comes back up faster than it dips down, which makes no sense. And then there's the dips later are, you can see there actually is a family of dips that occur. And these are all very large dips, by the way. Even this, what looks like a little one here, is only little by comparison. It's actually quite large. But this one
that
here
is really weird looking.
Yeah. It is. That's exactly what the citizen scientists said. Now this was the Kepler automated timeline didn't catch this because it was too strange. It was human eyeballs looking at it that said, "What is that?" and reported it back to the science team and said, "We found something that just doesn't make sense. There must be something wrong with the instrument or something." And
that would be my natural reaction to say, well, this has got to be a measurement defect.
Well, they looked at that, and they have.
Oh, I'm sure. Yeah.
Kepler has a very sophisticated process for weeding out bad measurements, and it passed all those filters of flying colors. And so it's and this is in the paper. They discussed that, how they went back to the Kepler instrument team and said, "Are you sure that this is not just a glitch in the data?" Well, if it was a glitch in the data, you'd see neighboring glitches as well. You wouldn't just see this one very specific star. And
No.
so that they actually corrected for everything that they knew that could possibly be wrong with Kepler, and they still got this weird stuff. And I would point out, this paper goes on at length about possible explanations for the data.
I found it interesting that there's no evidence for secondary eclipses. You don't see these objects passing behind the star, as you might expect.
A little bit of increase in the in the light curve as it goes behind the star. Yeah, it just none of it makes sense.
No, it doesn't.
Have they looked for like a rogue brown dwarf going through there with other things trailing along in its gravity well?
A rogue what? Sorry, say again.
Like a brown dwarf?
Oh,
possibly going through with things in the gravity well trailing behind it.
Which
brown dwarfs don't really emit infrared, do they?
Yes, they do.
They do? Okay.
Yeah, they're pretty strong infrared.
For some reason, I was thinking they were pretty cold.
They are, but that's why you see them infrared. You don't really see them in visible light.
Okay.
I wanted to just run a question here because I'm looking at the charts. I mean, I've got the PDF here to open. It's kind of, I'm wondering, did the data end at 1600?
Yeah, pretty much does, yeah.
Because there is a start of a dip. I wonder if they missed out and there actually is a 800, is that days? 800 day, that there might actually be an 800 cycle there, or that the data stopped before they saw the
recurrence.
As you know, Kepler went through an anomaly and had to replan its mission. So
yeah, and then also there's a chart right underneath it. Was it normalized flux? Looks like from 1500 to 1580, and there's two dips that kind of almost. I mean, one's larger than the other, but they look kind of. They have the same kind of. There's like a little dip, and then a big dip, little dip, big dip in it. I wonder if that's significant.
Well,
if that's the same object, but it's on the other side of the planet or the star.
Yeah, that's explained in the text. Essentially, each one is zooming in on, for example, the last panel is a zoom in of the one before it to show all the little wrinkles and subtleties that go on as that thing was passing by. It was a very complex event, that second one.
Mm-hmm. It looks like there's a big buildup leading to it. You've got a little bit of looking at the chart. You've got a little bit of added light, presuming something was behind the star. But then you got like a buildup of a lot of unstable fluxes, and then you have those massive drops in luminosity.
Yeah. Again, if you look at this paper, these professional astronomers did everything they could to explain it with known phenomena, and
could it be a weird convergence of events that they're not thinking of? Like,
I think
Buck
it's
was-
definitely that.
like Buck was talking about, an asteroid belt or interstellar dust or something like that going through, combined with a large mass and solar spots, sunspots, all occurring at once.
It's certainly not an asteroid belt.
Yeah.
For the
I mean,
reasons
just that-
stated.
Yeah, but just all of them combined together, just a whole bunch of things adding up to the massive drop. Individually, they're very minuscule, but it's a cumulative effect.
Well, but if you look at the first event, it's really clean. That's a single event.
Yeah.
Yeah.
And was that first one the one that had the reduced slope of the trail off?
Yeah. If you, I don't know, Buck, I'll put the link in the chat so everybody can look at it.
I've got the one from Slate right here.
Yeah. Well, the Slate one is, kind of boiled down a bit.
Yeah.
I'll put this link here, the PDF link. You can just go bring that up. It's
Now a trailing a trailing series of objects would tend to produce that sort of curve. Now that I can get on board with.
Well, we don't know. Yeah, it certainly the second event certainly does look like a lot of leading and trailing events.
Well, yeah, but the first one, it comes in more quickly, like you would expect of a standard occultation, and then it trails off at a lesser slope, which would suggest that there's material trailing. Because the dimming effect reduces at a slower rate. To me, that suggests that there's occulting material trailing the primary.
Well, but it would also maybe we don't know, but it would have to. It's pretty strong effect, and it's a very smooth effect. So
yes.
So it looks to me almost like the aspect of the thing is changing. Whatever it is that's doing this, and it's very large. It's occulting 15% of the star, right? That is
Well,
slowly,
that would do it.
Turning.
I hadn't thought of that.
But that means it's a highly asymmetrical object. So by highly asymmetrical, I mean just even subtly asymmetrical is weird in this context. Because we're talking about something very big, something that's on order of the size of a star.
Because of the inclination of the star, we might be seeing grazing transits as well, where something's just cutting across
the
top or the bottom.
Not quite in the orbital plane of the sun, of the star.
Well, it's certainly not in the rotational. The plane that's the symmetric plane of rotation of the star, because that they measured that, and it's something like 68 degrees.
We can rule out star spots pretty much as well, because if it was star spots, we'd see the same spots rotating in and out of view
Yeah, and this thing
The
rotates
star-
it in less than a day. So you'd see it a lot. You
Yeah.
see daily rotations.
We'd get very regular dimming if that were the case, and we don't see that.
Yeah.
I listened to Kimberly Cartier, who's one of the Jason Wright's co-authors. She was on the weekly Space Hangout earlier on today.
Oh, cool.
And she was very cautious. She was quite cautious about what this might be.
As she should be.
She played down, yeah, as she quite rightly she should be, and she was.
I mean,
she did.
Yeah.
Well, she did say that they can't rule out alien megastructures, but that's always got to be the last
well,
resort.
This is almost like a Zach Wienersmith cartoon, right? I mean, we can't rule out X, and then so the media says it's X.
Yeah.
Right. This could someday lead to a cure for cancer. Cure for cancer discovered.
Now, Pat does have a question about could this be just a very odd varying of the star's light output?
Well, they looked at that, and there are some known stars that do vary in their light output, and they couldn't find any correlation between this and any known type of variability in stars. And the thing that's been very, very carefully modeled over many generations, how stars' light output varies. And to vary that fast is not easy to make that happen, but we think we know, what causes that. And we're not seeing that signature.
This was just over the course of a couple of days, really.
Yeah.
Well, about 14 by the second 14 days, but still, that's fast for any kind of a solar event.
There are a lot of variable stars. In fact, some of them are naked eye visible. But in fact, there's people who that's their whole hobby is going out and observing variable stars. There's a lot of them, and they're very well characterized, and this doesn't behave like them. And that's in the paper.
No.
Yeah, that's in the paper. They have they considered a couple of different classes of variable stars, and it didn't match up. So if it is a variability, it's a new kind that nobody's modeled yet. And also, I should point out, they looked through the whole Kepler field and could not find another dipper like this.
No, but a lot of Kepler data doesn't make it down to Earth.
That's true.
Kepler, there's a computer system on board the Kepler spacecraft that runs an algorithm to detect planetary transits, and it generally gets rid of all the data that it doesn't think contains any planetary transits. So there's a possibility that similar events have been looked at and just junked. We don't know.
True. And I think that may be something that will affect how they process data on TESS and Plato and other missions like that. So they looked at, this paper really just summarizes it's 14 pages. It looks at 15, what they considered, and summarizes the arguments for and against each of those things. And you'll notice the word alien does not appear in here anywhere. If you search for alien,
I'm quite surprised that no one has claimed to have deciphered the alien broadcast yet.
Oh,
the signal.
We haven't asked Mr. Hoagland what he thinks yet. And
it's obviously a message.
I'm going to steal that idea.
Someone can decipher it.
Well, actually, if you look in Jason Wright's paper that came out yesterday, they talked about how you might decipher such a message in some detail. It's an they didn't claim that there was a message. They just said if somebody was eclipsing a star in such a way as to send a message, how would they do it? What would it look like? It's an interesting paper.
Yeah,
Uh,
it is.
they don't claim.
It occurs to me
that.
It occurs to me that if someone was broadcasting prime numbers or something obviously, something that you could recognize, you might
From
not
the
be
movie
able to
Contact,
recognize
perhaps.
it.
Say again?
From the movie Contact, perhaps.
Yes.
Well, yeah, that was a
But
radio signal, but yeah.
You'd have to have the correct line of sight. Who knows? It might. They might be broadcasting a message.
They don't know we're here. They just know that there may be stars within that line of sight that could see it. Right?
Well, plus if they're dimming the entire star, it doesn't matter.
They're not dimming the entire star.
They're dimming
Well,
about.
Well, how do you know what they can do?
If they can dim the entire star, I don't want them showing up on our doorstep.
Well, I don't know. They might have some pretty darn good chefs or something. I don't know.
Well, I think we can, in the noisy data, I think we can translate it to pretty much anything. So, Adam, what do you want the message to say?
Hello?
To serve man.
Pat just said, do you think this could be a we just got lucky event?
Well, we did. Yeah. All transits are we just got lucky.
Yeah.
Yeah.
I mean, whatever this turns out to be, it is going to, it's new. We haven't a clue. It's that old saying that the key to science is not eureka, but hey, that's funny.
Mm-hmm.
Right. And it is funny. And
we don't have a clue what it is.
We don't.
It's
true.
No.
It's a mystery, and I mean, it's driving me crazy already. And I really envy the people who know what they're talking about in terms of they have this new thing out there. It's big, it's unexplained, and the answer is just waiting for us to figure it out.
Well, so clearly we need some follow-up observations on this star. Hopefully this paper will stimulate the funding that's required in the telescope time. And I know from what I've seen in various blogs that the SETI community is fascinated by this, and are going to be looking
Kimberly Cartier said earlier. She said earlier that SETI are planning radio observations towards the end of the year, or maybe January next year,
or possibly sooner. It could be the Allen telescope arrays looking at it right now. We'll find out later. I mean, the chances of catching a radio beacon are not very good, but it'd be a shame not to look, right? So they'll look at the star, they'll learn what they can, but I think probably the most promising follow-ups will be in infrared and maybe detailed visual observations with big telescopes, and try to resolve. For example, what is the radial velocity curve really look like? Can we find planets from that? What planets are there, if any? Because you can't always find planets with the transit method. In fact, you only find a tiny fraction of them. And so radial velocity can find a few more sometimes, especially if they're big planets. And then, since we're not going to have 24/7 transit watch on this star for a while yet, but there are missions planned in the near future that we'll be able to keep an eye on it, or at least for some of the time. including Plato
Yeah.
and Tess. So
They're supposed to be concentrating on the local solar neighborhood, though.
they are.
Plato is supposed to be looking at sun-like stars, and Tess is gonna look at.
Well, I think
stars
this would
within-
qualify as a sun-like star, or pretty close to it.
Yeah,
It's fairly
it's
far
just the
away,
distance.
but yeah. But I mean, if you know there's something weird transiting it, you're gonna have to try to reduce
I'd
it.
like to see Spitzer. I'd like to see Spitzer, the infrared space telescope, take a look at it.
Yeah, you know, I'd like to see. I'd like to see the whole electromagnetic spectrum: X-ray, gamma ray, ultraviolet. Is there anything else weird about this star? That, you know, and if the answer is nothing else is weird about it, no photons are coming out of there that aren't expected, then what you know, we have to figure out what happened here, and hopefully we can watch it around the time when there should be some stuff flying in front of it, see what it is. Whatever it is, it's inclined in an orbit that I wouldn't expect planets to be in. So,
Relative to the star.
yeah. Well, I mean, the star, the spectroscopy, the best fit to the spectroscope measurements that they have is that the star is not right at it's not spinning right at a right angle to us, like you would if you had a nice orbit plane going in front of us.
Somebody said like 60 something degrees.
68.
68 degrees.
Now, I think that's a preliminary number, but I don't think it's going to, it has some error bars on it, but it's not huge.
But that's a pretty sharp angle.
Yeah, what that means is that we probably wouldn't see planets passing in front of the star.
Yeah.
Because there's a lot of angular momentum gets stored as the star is forming. A lot of the angular momentum gets stored in the star. The rest of it goes out into the planets that are forming, and they should roughly line up. The star's angular momentum should roughly line up with the planet's angular momentum, and it's not going to be perfect alignment, but within a small number of degrees, it should line up pretty well. Our own sun is spinning in a way that is pretty well lined up with the planets go around it. And
what's in the neighborhood of that? Is it in an area that's is it like a spiral arm that's more dense?
It's not that far from us. It's only 1,500 light years, so it's a neighboring star. About 1% of the distance of the whole size of the galaxy. So it's nearby.
Roughly what direction is it in galactic terms?
See, I can get the galactic coordinates up here. I had them just a moment ago.
Left.
It's to the left.
It's roughly parallel to our own neighborhood in regards to where the galactic center is.
Okay, so average stellar density around this star is equal to ours.
Yeah. It's about the same distance from the galactic center.
Yeah.
So it's not, and as the paper points out, there's nothing unusual about the star. It's a very conventional F-type star, a little hotter and a little larger than the sun. So it's probably a little younger than the sun, but they believe it's a mature star, and doesn't have a big debris disk around it. So the next step is going to be follow-up observations, and then, maybe something will come out of that, or maybe the answer will be, gosh, this is just another very ordinary star. And
The strangest thing would be if we see nothing.
I agree. Yeah. You put the James Webb Space Telescope on this in 4 or 5 years from now, you might see
Well, one thing we need to answer this question is more cowbell.
Zero Villa has translated the what the secret message means. It says more cowbell.
Well, now that's if the cosmic Christopher Walken is out there. I've always wondered if he might be an alien anyway, but
I think that's getting ready to become the tagline of this podcast.
well, we got to come up with our own one. Can't be from Saturday Night Live.
The Unseen Podcast, now with more cowbell.
42 more.
15% more cowbell than other podcasts, guaranteed.
I like that one. I'll have to stop by a music store tomorrow and get a cowbell. I'll get one of those little drum stands and a cowbell. Ding, ding, ding.
I found my bull bell. I'll send it to you.
I'm my son plays percussion, so I'd love to get him a cowbell.
Huh.
Yeah, he's only in middle school band, which is like I don't know how that's probably sort of the paradigm for cacophony is middle school band, but
well, it's better than having him beat on the flat screens.
He's he's actually, I think he's showing some talent. He might, 4 years from now, I might have a band in my garage. When the boys figure out that's a way to get girls is to have a band, they.
Mm-hmm.
Let's see. So now let's talk a little bit about the media coverage of this thing. The alien megastructure did not come from the science team. And it didn't come from Phil Plait, who put out an article saying, well, it's probably not aliens, guys. Although the word probably there has a bit of a, you can interpret that a couple ways. Nobody really.
Weasel word, perhaps.
Well, the word probably, when somebody uses the word probably about something that's completely unknown, they're not really talking about a frequentist interpretation where they mean, well, it's, odds are 1 out of 30 that it's not, that it's aliens. They mean, I don't believe I don't believe very much that it's aliens. That's what they're selling you.
Yeah.
It's sort of the more Bayesian interpretation where it's a measure of belief. And that can be formalized and made very, very self-consistent. But when somebody like Phil Plait says it's probably not aliens, he means, well, I can think of lots of cases where it could be not aliens, and I don't really like the idea of aliens because it makes me uncomfortable. So I'll say probably not. But really, what it is it's the paradigm that astronomy has is you look for natural explanations first, and
not just astronomy.
And that but frankly, that's worked. That's worked really well. I mean, if they went off on the alien tangent first, well, first of all, with aliens, you're dealing with something you have no idea what you're talking about, and whereas with natural objects, there's at least some hope you can model it. How are you going to model aliens? I mean, nobody knows what they're talking about.
Silver jumpsuits.
Well, yeah, other than silver jumpsuits, I mean, and
yeah, I mean, use Occam's razor and look for the most naturalistic explanation first.
Well, yeah, Occam's razor says don't invent anything that you don't need to invent, right?
Yeah.
uh,
Yeah, which it's a rule of thumb. It doesn't always work,
right.
but it's still fairly dependable.
Well, but I mean, really, it says essentially, if you can construct these data out of something you already know, then you're done, right?
Mhm.
You don't have to invent something new. But if you can't, then you've got a real anomaly. And sometimes paradigms collapse because of anomalies. Sometimes they simply solve them and move on. But what has kind of interested me is even though this is, the history of astronomy has been finding weird things out there and then explaining them in terms of natural events that are initially quite baffling. And I think I mentioned earlier gamma rays, bursts, and pulsars. The media is not going to be happy with that. They're going to jump all over the alien megastructures, right? Even though, so I don't know. What do you guys think about the coverage that we've seen so far?
About the what we've seen?
Coverage.
Well, everything that I've seen has included very prominently the alien structure hypothesis.
Yeah. Because
and
otherwise you wouldn't see it.
It's clickbait.
Right.
I don't mind. I don't mind particularly if it gets people interested in space and astronomy. Then I don't mind so much the alien megastructure story. I don't think people are that stupid. A lot of people will take it for what it is.
But you don't have Fox News in London, do you?
Oh, we do.
They have the Daily Mail, though.
Yeah, that's the tabloids and stuff are a lot where a lot of this has come from. My problem with them throwing out the alien superstructures outside of, everybody's fan favorite George Tsoukalos, which you guys should be able to see his picture here. But my problem is that it gets people excited, but then when they realize that no, it's probably not aliens, they get disappointed, and it causes them to lose trust a little bit.
Who is this guy?
Oh,
you don't know.
You don't want to know.
Okay. George Tsoukalos, who, if I remember right, even though he has a Greek name, he's a Swedish national. Started out as a sports writer for weightlifting, and now he's on everything to do with ancient aliens, ancient astronauts, and his hair gets, when he first appeared, slicked back hair, very, very presentable, and now he's got this wild do thing going, and personally, I think he's just being abducted really slowly. But he's a crazy, anything. I saw a show the other night where he was managing to tie the Lake Champlain monster, the Loch Ness monster, the Kraken, and several other old water myth monsters into the alien mythology. I think I had an aneurysm.
He's done the UFO shows. He is the publisher of, I forget which magazine.
It's like Ancient Astronauts Weekly or something.
It was like 40. It's been a long running magazine, and I think Von Daniken, the other, has been a major contributor to this magazine. I want to say 40 in Times, but I don't think that's
no. I don't think it's 40 in Times.
No, he's not in.
Von Daniken's
40 in Times.
dead, isn't he? Or he should be.
No, he's still alive.
He's still kicking.
Oh, could he please be dead?
Yeah.
But he Tsoukalos. I pronounce it Tsoukalos, but I think he's the executive producer. He's footing the bill for that show. He's not. This isn't something that a production company slapped together. He's a major contributor financially to putting that show on the History Channel. So,
as I heard the other day, if I didn't have ethics, I could make a ton of money.
oh yeah, we all can.
Oh, look him up on Wikipedia at this picture of him. I'm sorry, but this is excellent. This needs to be the image for this episode.
Okay, show me.
All right, give me just a second here. This is, oh, I love this.
Folks, we will have this on the show notes, so don't despair if you're listening to audio only.
Oh, he looks like a cracked up pimp. All right, can you see that? Bottom of the Wikipedia.
Oh, wait.
All right, give me. There we go. I'm hoping it's up now.
Oh, yeah.
Yeah, that little picture right there.
Yeah. Well, it came up and then it went down.
Okay, that's kind of a special little look at him, and I guess that's a bathrobe. I'm not really sure. I'll post a link to his Wikipedia page.
You're not making me love him. That's for.
Oh, that's not my goal. This guy personally irks the living hell out of me.
Yeah.
I mean, he's just managed to tie. He can find a way to tie Oreos, Twinkies, and Kentucky Fried Chicken into some kind of space alien conspiracy.
Well, that would taste better than.
Yeah, but there's his.
That doesn't sound like a particularly challenging mashup.
Oh yeah, but he'd make it into a threat.
Okay.
So let me see. He is the director of Eric von Daniken's Center for Ancient Astronaut Research.
Oh.
And
my God.
Legendary times.
Wait. Oh, it gets better. And he has appeared on the Travel Channel, the History Channel, the Sci-Fi Channel, the National Geographic Channel, as well as Coast to Coast AM.
Oh, well, if you've been on Coast to Coast AM, I'm sorry, I apologize. He must know what he's talking about.
He went to Ithaca College, and the dude actually speaks 5 languages. I'll give him credit there. Wow. English, Greek, German, French, and Italian, and those really aren't that similar, so...
But he's a Swedish national, doesn't speak Swedish?
Yeah, that's kind of funny. Or he does speak Greek. Well, his family's Greek. He was born in Sweden.
Oh.
Switzerland.
Switzerland. Let me see.
Oh, well, the German is spoken in Switzerland.
Swiss-born Greek writer and television personality. He is a personality, I'll give him that. Let me see. Oh, he's the founder of Legendary Times.
Yeah, that's the magazine I was thinking.
Which features articles from Eric von Daniken. Oh, and another favorite person of mine, David Childress.
Oh, God.
He's
in my permanent spam filter, but
this is like the little crackhead on the corner who hangs out with the pimps and the meth dealers.
Well, except he's got more bling than some of them.
They do the same amount of damage.
Yeah.
Oh boy.
Well, at least they provide an honest product.
I don't know. Yeah. I'm really conflicted about. I always welcome the chance to talk to people who have been taken in by the moon hoax conspiracies, and 99% of the people that I've run into are really interested in finding out about it. I'm sure there's, I guess I have talked online with people who, somebody was trying to convince me that this lake in Bolivia was evidence of extraterrestrials because it was super symmetrical. I'm seeing somebody, I guess this guy made up as a Kazon from Voyager.
Oh yeah,
Looking
where it says humans.
God, aliens. Yeah, up on the right.
Yeah, there's a meme where he just says, where instead of saying aliens, it goes humans. So, yeah, he's He's got a lot of memes on him, and I mean, just image search him. It's priceless. You'll giggle for hours.
Yeah.
Well, it would probably be funnier if I knew him, but I'm really kind of, I don't know. I'm of two minds. On the one hand, I hate the idea of people being really severely misled about reality, and to the point where they can't really distinguish the imaginative fiction and I just want to say imaginative speculation that's really outside entertainment. It really qualifies more as entertainment than serious rational inquiry. I'm torn between that and from a series of diagnostic lectures that I listened to where somebody pointed out, this guy who'd studied it for many years, he said, look, people who are into these things, they tend to be very imaginative, and they don't typically base their life around it or make any decisions or do anything they wouldn't otherwise do. There's a quote up on the screen. I don't know. Therefore, aliens.
That's pretty much how the dude operates. I mean, that's it. He'll just throw out some really random quote from Mike. You may remember or know off the top of your head the ancient Indian texts, the
the Vimana Shastra.
Something like that. But he'll throw out.
Guys, you're embarrassing a whole culture.
I know. No, there's this Vimanas. It's supposed to be a Sanskrit depiction of, I guess, the
Battle
god.
of the Gods.
Yeah, and they've interpreted it as being space aliens flying their spaceships, and it goes into this. Somehow they get from ancient Sanskrit, which there's even something. Well, it's the actual this Vimana Shastra, whatever this document is actually was channeled by a yogi.
The Vedas.
The Vedas.
The Vedas.
Yeah, it was channeled by a seer in the 1890s, 1900s, and the whole story is made up. It doesn't exist. There's nothing in the actual Sanskrit texts that they have found so far. There's anything close to this. This has all been made up by somebody and turned into it. There's a whole interesting story behind that. It's I think it had to do with part of the what's that? Not
transcendental meditation.
No, there's I'm trying to remember this Theosophical. It was part of the Theosophical Society, one of the early works out of that group.
Okay. So I just got an invite to go to one of their meetings.
Cool, go for it.
I'm tempted to.
Yeah. Give us a report.
I might do that. I just took my son to the Oklahoma Paranormal Experimentation Research Association fair. He was a little bumfuddled. He couldn't figure out. He's like, they think rocks heal? What? Why?
Yeah.
It was priceless. It was priceless. He was getting into arguments with the dealers.
Good.
So, but yeah, here's that picture I was telling you about on him being abducted very slowly. So. Yeah, but if you get a chance, just Google image search Tsoukalos. I mean, he's priceless. Okay. He really is.
Kids, stay in school and stay off drugs.
Don't write for bodybuilding magazines.
Well, so how did we get on that guy?
Tangent drink.
Oh, and aliens.
Bottom-
Aliens, yeah.
Yeah.
Bottoms up, everybody.
Oh man, I'm too late.
Well,
Paul and I are dry.
Yeah, me too.
I have one drop. Okay. So anyway, I just wanted we spent about an hour talking about this strange thing that came out this week. I just want to say that I encourage speculation on this show. I like speculation. Speculation is fun. Speculation is there are people who get paid for speculating. They're called science fiction writers. And they do it particularly well. And you know, so on the Unseen Podcast, you can speculate to your heart's content. You know, maybe tie in it a little bit to reality as best you can. But you know, we're kind of experimenting with ideas here, kicking them around. The grounding facts that we have in this case are interesting enough, I think, that you know we can move ahead, and we'll keep an eye on this story. I don't think this story is over. I think it's just starting. And you know, fortunately, there are people like Jason Wright who keep an eye on these kinds of things, and actually are looking for telltale signs of civilizations that are not, you know, SETI traditionally dealt with radio signals, and more recently with lasers, you know, with light optical signals. There was a big setback for that this week that I don't think I'll go into in any depth, but one of the major optical SETI researchers lost his job, and many people will tell you he should have lost his job, but maybe we'll talk about that some other time. But we had traditionally been looking for things like, well, if they want us to know they're there, they will send us a radio signal. And there are good reasons to believe that, by the way. It's not a completely stupid thing to look for. But then the next question is, well, what if they don't want us to know they're there, or they just don't think radio is a good way to contact other civilizations? Are there other ways to finding them? And people have been looking at things like, well, they might have an IR signature. They might have, they might be building things around their star that we could detect with our telescopes. And, you know, this is the first sort of little wow signal for that kind of search. It may turn out to be nothing, or it may turn out that we never can find an explanation for it. Similar to the wow signal, there was no explanation for that. There's a lot that can still go on, and so hopefully this will get some more follow up than the wow signal has, which has been the follow up to the wow signal has been pretty poor, I have to tell you. So, guys, let's go around one more time. Everybody gets to say a last word, and then I will wrap us up. Okay, so Adam.
I was just thinking it's a shame no one wrote awesome on the light curve.
The awesome signal.
Yeah. It is a fascinating story that is just going to run and run, I think. It'll be interesting to see what sort of decision the scientists make to explain this phenomenon. Personally, I still like the colliding planets idea. I'm going with the disruption of the planetary system by a passing red dwarf. That's my theory for now.
Okay.
We'll see.
Well, yeah, we'll see. I think that can be ruled out or in by further observation. Buck.
Well, I have learned a great deal about this announcement that I knew nothing other than I didn't like the alien hypotheses of these superstructures that were being proposed. As always, a pleasure to talk with such well-informed people, especially Paul and Adam on this time, and I look forward to more cowbell in the future.
Now, James.
This has been pretty interesting. I honestly, pretty much like Buck, I only heard the bits about the alien superstructure, and that's kind of a thing where I flip to the next page. And I'm sorry about the sucralose-filled tangent on that.
Oh no, that's all right. Tangents are not only allowed; they're required.
Yeah, but once again, had a lot of fun listening, and especially, like Buck said, you and Adam are pretty well informed on this, and I think I might actually learn something.
Mr. Bohler.
Yeah, same here. I was really disappointed that the that the media took on that that it's aliens, but I guess since they have to sell newspapers or advertisement, maybe that works for them. But I think it turned this into. I mean, it's a neat phenomenon. I think because today I just got or yesterday I think the first paper on New Horizon came out, and in that paper there's still more information coming down. They're interested in that area. Was it on Sputnik Planum? The upwelling of ice, and they're hoping that the 70-meter images are going to explain more what's going on there. But it's kind of a neat overview of what they found through to date up with the pass-through, that there's some type of water or something on the planet and things like that. So there's always neat stuff happening. So hopefully this turns out to be something neat. I kind of like Adam's thought about a red dwarf passing by. It may have already passed by, and now we might be witnessing the disintegration of a star. Maybe, who knows? Who knows what we're seeing? So it'll be neat to see what happens.
Yeah. Now, we didn't get to talk much about, and we should sometime soon, about the Pluto paper that came out this week you just mentioned, and also there's been some really, just yesterday, some really cool new images from Enceladus that I don't think anybody knows how to interpret yet. And of course, the Pluto images that have been coming down the last couple weeks have been gorgeous and baffling, as well as the Charon, the moon of Pluto, the big moon of Pluto. So we're just going to kind of have to wait for the scientists to do their job there. The images are stunning. The interpretation may have to await some serious hard work before anybody can understand. We won't fly by Pluto again for a very long time, so that's all the data we're going to get for probably a couple of generations, I would think.
Yeah, and if you hear about a conspiracy about Pluto, that upwelling there on Sputnik Planum is alien power source that is melting it. That's my fault, guys. I'm sorry.
You put that story just see how far it would go, huh?
When I did the interview with Stuart Robbins, I mentioned that, and we kind of joked about, great, I just gave some conspiracy people some fodder, so okay.
Well, they do know that Pluto is active, and nobody knows why it's active, which is cool.
Yeah.
It means that we have to rethink our understanding of the whole Kuiper belt, which is also cool. But let's face it, every time a spacecraft is flown by a planet for the first time, we've learned things that we didn't think we'd learn. So the universe is more complicated and weird and interesting than we give it credit for. And even without aliens, maybe we're the weirdest, most complicated thing in the known universe. We're also probably the most annoying thing in the most known universe. So anyway, I'd just like to say a few more things before we head out. And I thank the panel. But I did mention earlier that next week we were going to talk about transhumanism, a very different topic. It should be fun. We'll have a practicing transhumanist with us, somebody who's implanted things in his body, and he will tell us what those things are. He takes particular types of supplements and does particular types of things to his brain. I can understand why you might not think that that's very likely to be successful, but let's have a talk with him and ask him what he's about. I think that even if everything he's doing is wildly wrong, it still fascinates me that there is quite possibly a future in which we will merge with our technology, and that is something that is, I think, in 30 or 40 years is going to be a huge important issue, maybe even sooner than that. So we'll have him on next week, and I hope you'll join us. The panel's not set for that yet, but it could be some of the same people that are here right now. And as I mentioned, a week after that, James will be hosting, and he's recruited. James, you want to speak briefly about some of the people you recruited for that show? James?
Yeah, sorry, my mic got stuck. I have contacted Blake Smith of the Monster Talk podcast. I have contacted the guys from Blurry Photos podcast, and David Flora will be coming on, and I've contacted C-Web from C-Web's Paranormal Skeptic Academy, which they're all pretty good shows. They're all fairly skeptical. The Blurry Photos takes a more humorous slant at it. Blake takes he wants to know the science behind, the monsters. But they've all agreed to be on, and I've, send an invite to Mike Bohler also, because a lot of these cryptids kind of bleed over into conspiracy theories. It's kind of strange how that happens.
Oh, it bleeds over into paranormal stuff too, yeah.
Yeah, but there's conspiracy theories about the government is covering up abductions because they're done by Bigfoot, who is an alien who can phase in and out of this dimension.
Oh, man, they got me figured out.
Or is a prisoner, like Earth is a penal colony, and we're prisoners, Bigfoot's a prisoner, and it gets really weird.
Yeah.
A penal colony with decent wine sometimes. Okay.
Yeah, you just got to make sure that you say it right and say penal, not penile colony.
No, now you got me thinking the other way. I can't stop now. My dirty mind is turned on.
I'm glad to know I could turn you on, Paul.
Well, we old men are a mess.
So I will get busy and upload the irresistible desire to our transhumanist to appear on next week's podcast. I've got the Dropbox file all set to upload to him.
Oh.
Well, he's it's going to be fun. And I think it's probably the first of many episodes we'll do on related subjects. And I did a interview a long time ago with Nikola Danilov, 2013, about transhumanism. I'll put a link to that out. You guys can see it. We talked about things like he feels like that, cyclists who are caught doping, not to name any names, shouldn't have been disqualified from competing, because that's just normal augmentation of human capability.
Yeah. Giving them really strong arms.
Yeah. Some guy with strong arms.
He could carry a lance.
Because even though that's extra weight on his bicycle and some that they take around France going on a tour.
Yeah, but they took off a bit of extra weight, so.
So anyway, he thinks that's fine.
Well, Nicola does, yeah. And Nicola's an avid cyclist, so I'll put a link to that in the show notes. You can listen to that if you want. All kinds of things that we already do to augment ourselves and with technology.
Can you imagine the start line of a 100 meters race with the competitors banging things up their noses, snorting powders and injecting themselves prior to the race?
They already do that.
You haven't been to a track race recently.
Saturday Night Live did a bit about the steroid enhanced Olympics. Wasn't it Kevin Nealon goes to lift the weights? He just pulls his arm. I mean, his arms just kind of pull off, and it's just blood going everywhere. And stuff like that. Trying to lift like 2,000 pounds, and
right. The thing that came up recently when some folks in the Paralympics who are disabled, or have lost limbs or something like that, have found that they can actually go pretty fast on those artificial limbs.
Oh, the blades.
Yeah, and it can get to the point where they can actually go faster than somebody without them. And then the question you get into is, why is there a Paralympics? It's a very complicated subject. I really don't care about the sport angle that much, but it does raise some interesting questions. Okay, folks, thanks for sticking with us this long. And I'd like you to go to unseenpodcast.com, where you can find all the links that we've just promised to put in the show notes, including the links to the paper about the Where's the Flux star and its strange dips in its light curve. We'll also have links to Jason Wright's paper, Jason Wright's blog, and many others. And of course, pictures of a guy with weird hair. And so please continue to join us. Also, I hope you will also look up wowsignalpodcast.com. The Wow Signal podcast is still around. We just put out a burst recently. The burst was Why Interstellar Flight is Hard. I hope you'll listen to that, especially if you don't have some idea why interstellar flight is hard. It's at a very basic level, not intended for the real wonks in the area, but people who just wonder, how long would it take to get a starship out if we just put it on a big rocket and shot it out of the star? That's in burst 7, and very soon, in fact, next Friday, I'll be doing an interview with a couple of asteroid scientists, and we'll have that out shortly about asteroid mining in the Wow Signal. So go to wowsignalpodcast.com for that information. You can email us at unseenpodcast.com. If you're interested in being a panelist on the Unseen Podcast, it is an open participation podcast. Anyone who's interested in being a panelist can be a panelist. Email me at unseenpodcast@gmail.com, and I will tell you how you can do it. Or just go to unseenpodcast.com and look at the FAQ. Pretty much all the information is there that you'll need. And again, we come out every week, usually on Saturday. And usually I'm the host, but sometimes it's James, sometimes it's Adam. And if you are interested, if you've been on the panel once or twice and would be interested in being a host, please contact me. I would like to have a cadre of 5-6 hosts that come on a few times a year. And no technical knowledge is required, just be able to speak and listen. And hopefully in English, because I'm kind of limited that way. And we hope to see you again next week when we talk about transhumanism. For now, this is episode 29 of the Unseen Podcast. I'd like to thank my panel, Adam Smith, Buck Field.
Thank you, Paul.
James Garrison.
Thanks, Paul.
Mike Bohler.
Thank you.
And this is your host, Paul Carr. It is the 16th of October, 2015. We'll see you next week. Goodbye.